Hello guys, what we are going to talk about today is what's inside a DJI Phantom battery controller basically. I had a problem with one of my DJI Phantom batteries. It would shut off in mid-flight, and I was lucky enough to catch the drone with my own hands. But if I didn't, I would have destroyed the drone. Basically, this is a fairly complex circuit to start with, and it seems to have multiple PCB layers, because if one puts it under the light, you really cannot see, light cannot pass through, so there are more than one layer in between. What, in a nutshell, it seems that DJI used two microcontrollers. One, which is this one, it is a BQ30Z55, and this one seems to be a dedicated LiPo controller. This one controls the charging, the self-discharge and the general battery monitoring through these shunts and the thermistor. It's a fairly good microcontroller, because it is also energy efficient. But also what they did, they just put in another microcontroller. This one is an MSP430. It's fairly old, because these, I think the MSP430 G2, it came out back in early 2011, if I recall correctly. What this does in a nutshell is store the firmware, that when you update a battery, DJI sends the firmware to this chip, and in return this chip controls this slave chip. Both of these are microcontrollers, by the way. The good thing about this MSP430 is that it's fairly low power. It's very energy efficient. I think it's around, standby current is around half a microamp or 1 microamp maximum. So it's fairly low power. Good job on DJI. There are also two shunt monitors. These are basically current monitors, and these are, let me check, these are 0.3 milliohms each, and they are configured in parallel, so that one makes them 1.5 milliohms. I think these can take a fair amount of abuse in terms of current, and what it seems these days go through another resistor, through another 100 ohms resistor, and into this microcontroller, the battery management, the Lion battery management. Furthermore, there's some other components. I presume this one might be a linear regulator, because these run at 3.3 volts, so there must be some regulator somewhere here. Well, let's flip it on to the other side. Okay, what we have here is the power section part mainly. We have 4 MOSFETs, and these are configured in series parallel for some reason. It seems, because I've done some tests, it seems that these two MOSFETs are fed PWM, because when I check their datasheet, I think these are, let me check exactly, TPH1R403NL. These are low power, low VDS, but high current. Drain current is fairly high if switched in PWM mode. These, I think they are operating, DJI is operating them in around 100 kilohertz, because according to the safe operating area, that's the only viable, option for high power current handling. In fact, what we can see here if it's VDS, let's say it's around 17 volts, so let's take 20 volts. Each will handle a maximum of 10 amps with respect to microseconds, 100 microseconds. So it makes sense that to put these two in parallel. That's what they actually did. They just put them in parallel. If we look at it again, we're assuming that it's 20 volts. Let us say 17 volts. So it would be somewhere around, 20 amp each. So these have a current capacity of around 40 amps if switched at 100 kilohertz. What we have here is the battery balancer circuit. There are these 4 transistors which feed the battery power through these 400 ohm resistors. I think those are 1218s, I'm not sure, but they're quite large as an SMD resistors. So presumably each cell takes 4.3 volts. So this one can output a maximum of 43 milliamps to keep the battery, each cell's balanced. So not that much power, but at least it's decent amount of current, to keep the cells balanced. Another feature that DJI have is the auto discharge. The auto discharge is controlled via these 2 other MOSFETs, and it seems to be discharging through these resistor, this 100 ohm resistor, which is fairly low ohmage, because 100 ohms at 17 volts, it translates to around 2.83 watts. So this must be working really hard if these are not switching PWM. Well, I think that's how they did it. Another thing is how this module communicates with the DJI Phantom. Basically, it uses I2C, because I2C is just a 2-wire protocol communication, and it's I think it's better than serial port, because serial port you have the two ends, they have to agree on a clock and so on and so forth, and they must have these similar clocks, so it's not that easy to put it in TXRX, and I2C is a fairly superior protocol, I presume. Well, I think that's just about it, because it's a shame that these batteries cost a fortune, and I don't, from my experience, it doesn't seem that the Phantom batteries are the best, most brilliant batteries ever. I mean, this one failed after around 8 cycles or so. So 8 cycles are nothing for a battery of this sort. Unfortunately, it was out of warranty, so I had no other choice but either to leave it there rotting, or at least dismantle it and see what DJI did on the controller. Well, in a nutshell, it's a fairly robust controller, to be honest. It's a shame that they chose not so robust cells for DJI Phantom. But it's a shame. Well, if one have any questions, feel free to ask. I'll try to help anyone. I mean, this is everything I can talk about right now. Anyway, hope you have a good day.